You don't feel it at first. That's the terrifying part. Right now, in this moment, Earth has been caught by the gravity of a black hole, and everything looks completely normal. The sky is blue, the ground is solid, birds are still flying. You have absolutely no idea that in roughly 200 years, none of this will exist. So, what actually happens, step by step, from the first moment to the last? First, what is a black hole? One sentence: a region of space where gravity has become so extreme that nothing, not matter, not light, not information, can escape once it crosses the boundary. That boundary has a name: the event horizon. Cross it, and you are gone from the observable universe forever. Now, how does Earth end up falling into one? There are three realistic ways. 1. A rogue black hole. A stellar mass black hole drifting silently through the galaxy with no star system, no light, nothing to betray its location, passes close enough to lock Earth in its gravity well. We would have almost no warning. 2. Over millions of years, the supermassive black hole at the center of our galaxy, Sagittarius A, 4 million times the mass of the Sun, gradually draws our solar system inward. Not today, but the galaxy is not static. 3. A hypothetical scenario. A micro-black hole forms near Earth. This is considered extremely unlikely, but extremely unlikely and impossible are very different things. Here's the fact that stays with you. There are an estimated 100 million black holes in the Milky Way alone. Most of them are invisible. We find them by what disappears around them. Earth doesn't just blink out of existence. The approach is slow, and it starts long before the event horizon. The first thing that changes is gravity. A black hole's gravity doesn't pull evenly. The side of Earth facing the black hole gets pulled significantly harder than the far side. This difference, called a tidal force, begins to deform the planet itself. The oceans surge toward the source. Mountains crack along fault lines that have been stable for billions of years. The crust stretches. The interior of the planet, under stresses it was never built to survive, begins to fracture. Then the sky changes. As Earth gets closer, the black hole's gravity bends light from behind it, creating a glowing ring around the darkness. This is called gravitational lensing. The stars around it smear and distort into arcs. Every night, the black hole grows larger in the sky, a circle of absolute darkness, getting bigger, ringed by the compressed light of an entire galaxy being bent around it. At a certain distance, it appears bigger than the moon, then bigger than the sun, until half the visible sky is gone. Imagine watching the sky be slowly eaten. Every night the darkness grows. Every morning, slightly less of the universe is visible than the day before. Now we get to the part that has an actual scientific name: spaghettification. As tidal forces become extreme, everything, rock, ocean, atmosphere, you get stretched along the axis pointing toward the black hole, and simultaneously compressed from the sides. Not metaphorically stretched, physically. Atom by atom, the matter that makes up Earth is drawn into an impossibly thin stream, spiraling inward. The planet doesn't explode, it's unraveled. Now, here's where it splits depending on the type of black hole. For a stellar mass black hole, the collapsed remnant of a single dead star, the tidal forces at the event horizon are so intense that spaghettification happens before you cross it. You are stretched and destroyed in open space before you ever reach the point of no return. For a supermassive black hole, millions or billions of times the mass of the Sun, the event horizon is so large that tidal forces at the boundary are actually gentle. You would cross it without feeling anything unusual. You would be inside a black hole and not know it. Spaghettification comes later, as you fall deeper. But here's the part that makes physicists uncomfortable. From your perspective, falling in, time passes normally. You cross the horizon, you fall deeper. You experience everything. From the perspective of someone watching you from outside, you never cross the horizon at all. They watch you slow down, freeze, fade. The light reaching them from you gets stretched to longer and longer wavelengths until you vanish. To them, you are frozen at the edge of a black hole forever. To you, you crossed it moments ago. The universe doesn't give you a clean death. It gives you one that depends entirely on who's watching. Let's go inside. Inside the event horizon, something happens to space and time that has no equivalent in everyday experience. the dimension of time, and the spatial dimension pointing toward the singularity, swap. Moving forward in time becomes the same as moving toward the center. You cannot stop falling toward the singularity any more than you can stop time from passing. It is no longer a choice, it is the structure of space-time itself. At the center, the singularity, a point of infinite density, infinite curvature, a place where our best equations, general relativity, quantum mechanics, every tool physics has ever built, produce answers that don't make sense. We say the physics breaks down. What that actually means is, we don't know what's there. No one does. Not yet. But the story doesn't end there. In 1974, Stephen Hawking showed mathematically that black holes are not permanent. Over an incomprehensibly long time, longer than the current age of the universe, multiplied by itself, trillions of times over, black holes slowly lose energy as faint radiation leaking at the edges. Hawking radiation. Eventually, the black hole evaporates completely, and everything inside it, every atom of rock, every drop of ocean, every trace of everything Earth ever was, returns to the universe as featureless thermal radiation. The information is scrambled beyond any possible recognition, but it isn't destroyed. Not quite. Everything you ever were becomes radiation. Indistinguishable from noise, the universe forgets you, but it keeps you. You're still standing on Earth, the sky is still blue, the ground is still flying, but somewhere in this galaxy, right now, there are 100 million black holes moving silently through the dark. We found a handful of them. The closest known black hole to Earth is 1,560 light-years away. We found it in 2202. Before that, we didn't know it existed. How many are we not seeing? The James Webb Space Telescope recently captured something near the center of a distant galaxy that our current models say shouldn't be there. Scientists are still arguing about what it is. Some think it's a new class of object entirely. That's the next video. If the universe keeping you as noise sounds like peace of mind, subscribe. The next one is stranger.